All right, guys, here is our second lesson today. We're still going to use our matrices. We're going to get into scalar multiplication and doing more adding and subtracting. Okay, here we go. All right, so scalar multiplication, what this is when we multiply the entire matrix by one single number. That's it. Okay. So if I'm going in the order like we did before, the size of my matrix, it doesn't matter because we're multiplying the entire thing by just one number. So here with 4 times matrix A, okay, let me get my pen. We're going to take the number 4 and we're multiplying it to everything in matrix A. Like that, everything. So 4 times the entire matrix A, well, 4 times 4 is 16, 4 times 2 is 8, 4 times 0 is 0, 4 times -1 is -4, 4 times 3 is 12, and 4 times -2 is -8. That's all scalar multiplication is, right? Order, size, does not matter with scalars. Number 2, we're going to multiply my entire matrix C by the number 6. So that's going to be 6 times the matrix 4, 0, 2, and 1. 6 times 4 is 24. 6 times 0 is 0. 6 times 2 is 12. 6 times 1 is 6. That's it. That's all it is. Easy. Even though it's a -4, it's still the same thing. You're going to multiply all matrix D by the number -4. So, -4 times 5, -20. -4 times 2, -8. -4 times -1 is 4. -4 times 0 is 0. That's it. Okay? Here, we're going to add and subtract, and we're also going to multiply by a scalar. Okay, so here, just like order of operations, right? We do parentheses first, then we move out. So here, see how it's 3 times C plus D? Well, I need to do C plus D first if I can, then multiply all of that by 3. Okay, so again, the size of our matrices matter. Let's go ahead and just write these down. This is a 2 by 3. This is a 2 by 3, this is a 2 by 2, and this is a 2 by 2. So when it comes to adding and subtracting, A and B can go together, and C and D can go together because they're the same size. Right? So number 4 wants me to do 3 times C plus D. So 3 times C plus D. They're the same order, they're the same size matrix, so I can put these together. When I add those together, it's going to give me 9, 2, 1, and 1. And now I multiply everything by 3, which gives me 27, 6, 3, and 3. That's it. So order of operations, still a thing, just make sure you can do it. Number 5, we're going to do the scalar number of 4, and we're going to multiply it to A plus C. Okay, look at A and look at C. 2 by 3, 2 by 2. The parentheses, we can't do it. Okay, so my order is not the same. So since my order is not the same, we can't do this. We can't do the A plus C. Right? Here we're going to solve for x, right? So just like last time, we have 2 times matrix x is plus 4, -5, 1, -12 is going to give me the matrix 10, 1, -7, and -2. All right, well, we know my matrix A is going to have to be a 2 by 2, right? Because we're adding. So we know the size of it. I am going to subtract this matrix to the other side first. That's going to give me 2x is equal to, so I'm going to subtract it over here. 4, 1, -5, -12. So I'm going to subtract it over. 10 minus 4, 6. 1 minus negative 5 gives me a positive 6, right? Becomes 1 plus 5. Negative 7 minus 1 is negative 8. Negative 2 minus negative 12, so negative 2 plus 12 gives me 10. All right, so 2 times a matrix gives me 6, 6, negative 8, 10. Okay, so that means I have to take half of each one of those, divide all of that by 2. If I divide everything by 2, we're going to get 3, 3, negative 4, and 5. You can always plug it back in to make sure it works. So 2 times 3, 3, negative 4, 5. That gives me 6, 6, negative 8, 10. And then add that with 4, negative 5, 1, negative 12. And it does give me 10, 1, negative 7, negative 2. All right, so we're solving just like we've always been doing. It's just a whole grid of numbers that we're solving for. All right, this one's a bit of a challenge, but I'm fairly confident you guys can do this one. I would like you to pause and try. I want you to pause the video. I want you to try this one, okay? Go ahead. Check your work with mine. The first thing we had to do was multiply my first matrix by the scalar of 4. Then I subtracted the entire matrix over. That's what's happening in the green. Then to get rid of my negative 1/2 that's now being multiplied, I multiply by negative 2. So negative 2 times negative 1/2 gives me a positive 1. Do that to both sides. That's my white. So my missing matrix is the matrix negative 22, 14, 28, and negative 20. How we do? Want to do it again? Because we are. All right. So I want you to try this one. So pause and try. I'll see you here in a minute. All right, your answer matrix here should be the matrix 3, negative 1, negative 4, and 1. So again, multiply my first matrix by 5. Subtracted that matrix over, that's in the green. I'm left with 3 times my missing matrix equals something else. So I'm going to multiply by 1/3, which is the same thing as dividing by 3. Okay, so I divided 3 from both sides. So I divided each piece of my matrix by 3 to get the answer 3, negative 1, negative 4, and positive 1. All right, that's it. That is it for scalars. All right, you have an assignment. It has all this on there. I think the notes were kind of a little bit more complicated than the actual worksheet is, but that's good for you. Let me know if you have any questions. Get the worksheet done. There are 22 questions on it. And reach out. Let me know if you have any questions. All right.